Okay, so today is 5.4, and this is solving multi-angle trig identities. Sorry, trig equations, not identities. So this is our last part for solving equations, and then we'll have our quiz on Friday. So we're still focusing on solving these equations in that interval from 0 to 2 pi. So it still means we're going to be giving our answers in terms of radians and everything in that rotation from 0 to 2 pi. But these are going to look a little bit different. So here is example 1. We've got 2 times the cosine of 2x minus 1 equals 0. Right off the bat, this should bother you, okay? Because we've never had a 2 in front of our x before. And there's definitely a way we have to kind of work around that. This is the whole point of today. So this 2, what it tells me is that I will have to, I'm going to have to make 2 rotations on the unit circle to find all solutions. So that 2 dictates to me how many rotations I'm going to have to go on the unit circle to find all of my possible solutions. Up to this point, we've only ever had to do 1 rotation because this was always just a 1 there. So today we're going to have to do 2 rotations since the number in front of x is 2. It could be anything, right? I could have 5, in which case I would have to do 5 rotations. It could be a half, in which case I would only do half of a rotation. So that number tells you how to look at your unit circle to make sure you get all of your solutions. Now, the first part of this is just solving like normal. So all I'm going to do, like I would normally, is add 1 to both sides. That's no different. Now it gets a little different, and not quite yet, but our next step, we want to get cosine by itself. Okay, we're trying to get cosine of 2x by itself. So I'm going to divide by 2. But this is when I see the most mistakes being made. This 2 in front of the x, right? This 2x, it's trapped inside of the unit, inside of cosine. So when I divide by 2, the only 2 things that are going to be able to create a giant 1 are these 2 right here. So what I'm left with is cosine of 2x equals a half. Now, what I want you to do is I want you to imagine that this was just cosine of x equals a half. So I'm gonna put a little thought bubble off to the side here. So imagine, so let's treat this like it is cosine of x equals 1/2, and find the angles. Find our angles that would make that true. So we're just imagining that instead of cosine of 2x, we have cosine of x. Okay, so what would we do? Well, we would look at our unit circle or think about our unit circle about when is cosine 1/2. That's what we're asking ourselves. So when is cosine 1/2? 60 degrees. So that's our reference angle. So that's pi over 3 in radians. And what's the other one that has a positive 1/2? 5 pi over 3. Good. Now, here's the thing. In the past, we've just been able to say, okay, well, x equals that, and x equals that. Perfect. We're done. The problem we have here is now it's 2x equals this, and 2x equals this. So here's what I'm going to do. I'm going to write this as 2x equals pi over 3, and 2x equals 5 pi over 3. We're going to come back and revisit that in a moment. But here's the big idea. This is rotation number 1. So from rotation number 1, we got 2 possible equations set up. Now what we have to do is think about what happens when we do our second rotation. So if you imagine your unit circle, and I'll put it up here for those of you that are in the room, our unit circle, we found that pi over 3 and 5 pi over 3 are our solutions. What we're saying is we rotated around, we got to pi over 3, we saw that was a solution. We kept going, we rotated, and we got to 5 pi over 3, we saw that was a solution. And we get back to 2 pi, back to the beginning. What we have to do is now do another rotation. So we've already gone 2 pi, so we just have to add on 2 pi to whatever we had initially. So after one rotation, we have to do a second rotation. So let's do that. So rotation number 2. So what we're going to have to do here is take the angles that we found. I'm sorry, I don't have it up on the screen for you. We're going to have to take the angles that we found in the first rotation. So pi over 3 and 5 pi over 3. We take those 2 angles and we add 2 pi to them. So I'm going to take pi over 3. This is from rotation 1. And I'm going to add 2 pi. I'm going to take 5 pi over 3. And I'm going to add 2 pi. So I'm taking those angles from the first rotation, and I'm adding 2 pi. All right. Well, what do we need if we're going to add fractions together? Common denominators. So let's get my common denominators. We're going to have to multiply 2 pi over 1 by 3 over 3. And this part will take as long as it takes. And it all depends on how comfortable you are working with fractions. You might be able to go through this whole process without actually writing all of the steps down. Okay? Just depends on your comfort level with fractions. So rotation number 2. When we add pi over 3 to 6 pi over 3, we get 7 pi over 3. And when we add 5 pi over 3 to 6 pi over 3, we get 11 pi over 3. Now, remember, that's not what x is. That's what 2x is. So what ends up happening here is we get 4 smaller kind of equations that we have to solve. And I'm just going to number them so we know what we're looking at. Here's equation 1. Here's equation 2. Equation 3. And equation 4. I've got to figure out what x is in all 4 of those equations. So thinking big picture, all of those equations have 2x. If I want to solve and I have 2x, how do I undo multiplying by 2? Okay, I could divide by 2. Or what's the other option? What could I multiply by? 1/2. So I could either divide by 2 or multiply by 1/2. Since I'm dealing with fractions and I don't want to divide a fraction by a number, I'm going to choose the option of multiplying both sides by 1/2. So let me get rid of this so I can maybe have some space here. So instead of dividing by 2, I'm going to multiply both sides of each equation by 1/2. So I'm going to go through, write that on each equation. I'm multiplying both sides by 1/2. And then I just need to figure out what my 4 solutions are. So when I multiply fractions together, multiply the numerators and multiply the denominators. So here, I'm just going to multiply pi over 3 by 1, and pi by 1 and 3 by 2. So I get pi over 6. That's my first solution. Second solution, again, multiply by 1/2. We get 5 pi over 6. Let me come down to the last 2. Multiply by 1/2. We're going to get 7 pi over 6. And then finally multiply by 1/2. And we get 11 pi over 6. So we have 4 possible solutions. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are our 4 solutions. Now, it took us a little bit to get there. And we have to keep in mind that we are looking for more than one rotation in order to get all of our possible angles. Because if you look, all four of these angles, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, all fall between 0 and 2 pi. So we found all the possible angles between 0 and 2 pi. But if we had just stopped with the first two, we'd be missing 2. So we do the number of rotations as whatever the coefficient of x is. So that number of rotations could be anything, right? If we had like 3 rotations, that's going to add another 2 solutions to this, and so on and so on and so on. Okay, let's try another one just to kind of get the feel for this. So we are going to do one with 3 rotations. All right, so I'm going to, same thing I did before, solve it as if it's just sine of x. Okay, so I use the same process that I've been using. I'm going to add radical 3 to both sides. I'm going to divide by 2 because that's the number that sine is being multiplied by, not the number that x is being multiplied by. Okay? So we want to get rid of that number in front of sine. We'll take care of the number in front of x in a little bit. All right. So once again, I'm thinking about when is sine, I'll just kind of write that here. When is sine of x radical 3 over 2? That's our big question here. And then do 3 rotations. Okay, so figure out when sine of x is radical 3 over 2, and then do 3 rotations to find all the possible solutions. So I got to think about my unit circle, and I want to know when is sine of x going to be radical 3 over 2? Quadrant 1 and quadrant 2, and what's our reference angle? Pi over 3. Good. 60 degrees pi over 3. So we're at that pi over 3 again. So let's do this, and I'm going to try and color code this. So if my first rotation, I'll try and leave a little more space this time between each equation. So my first rotation is going to be at pi over 3 and 2 pi over 3. Okay, and that's when 3x is equal to each of those. So that's going to give me 2 equations. Okay, so for each rotation, I'm going to get 2 smaller equations I have to solve. I do not recommend solving this until you have found all of the possible rotation angles, and then go back and solve them all at the same time. So that's my first rotation. My second rotation. So now I need to think about when am I going to end up at pi over 3 and 2 pi over 3 after another rotation. So I'm going to add 2 pi to both of those angles. Now we are dealing with the same denominator as we saw in the first equation. So we're going to end up multiplying by 3 over 3 again to get our common denominator of 3. If our denominator was 6, then we'd be multiplying by 6 over 6, right? It's just all focused on whatever that denominator is. So I get pi over 3 plus 6 pi over 3, which gives me 7 pi over 3. And here I get 2 pi over 3 plus 6 pi over 3, which gives me 8 pi over 3. And then that's going to be what 3x is equal to. So 3x equals 7 pi over 3, and 3x equals 8 pi over 3. So that's my third and fourth equation. Okay, that's 2 rotations. I still have to do 1 more. So what I'm going to do is I'm going to take whatever I got for the second rotation and just add another rotation to that. So for the last rotation that we need to do here, so this is for the third rotation. Okay, I need to add 2 pi to whatever I got from the second rotation. So I'm going to take 7 pi over 3. Now, I've already gone through the process of getting a common denominator. I know that when I get a common denominator, I'm going to end up with 6 pi over 3. Right? So work smarter, not harder. And then I'll do the same thing here. 8 pi over 3 plus 2 pi. Well, we know 2 pi is the same as saying 6 pi over 3 at this point. And now I've got common denominators. So if I add 7 pi over 3 and 6 pi over 3, I get 13 pi over 3. We know that's what 3x is. And then if I add 8 pi over 3 and 6 pi over 3, I get 14 pi over 3. And I know that's what 3x is. So that gives me equations 5 and 6. So all 6 of those equations, if I look at all 6 of them here at the same time, they all have, I know it's kind of small for you guys, they all have 3x equals something. If I want to undo multiplying by 3, I have 2 ways I can do that. What's one way? Divide by 3. What's another way? Multiply by 1/3. I'm going to choose the multiply by 1/3 because I think it's easier to multiply 2 fractions together than it is to divide a fraction by something. Okay, so I'm going to multiply everything in all of these equations by 1/3. So multiply by 1/3. Now, again, as you do these, you don't necessarily have to show every single step like I'm doing here. You might be able to get there a little bit quicker. And I'm going to have you guys kind of work through these at the same time I am. Try and see if you can get all of the solutions. So the first 2 I did, I got pi over 9 and 2 pi over 9. I'm going to go down to equations 3 and 4 and do the same thing. So multiply by 1/3. Okay, multiply both by 1/3. We get x is 7 pi over 9 and x is 8 pi over 9.
So it's a little more pi.
And then the last 2. We get 13 pi over 9 and 14 pi over 9. So we have 6 solutions to this one. Now, once again, what I ended up finding was all of the possible solutions between 0 and 2 pi. But I had to do 3 rotations around the unit circle to get all of those solutions. Those kind of looks like almost whited them out. Let me unhighlight those. I'll just circle them. So we have pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, and 14 pi over 9. Those are my 6 solutions. So let's just imagine for a moment that, that my original equation was sine squared instead of just sine. Then at some point I'm going to take the square root of both sides and I'm going to end up with plus or minus. I'm going to double the number of solutions I have. I would have 12 solutions here instead of 6. So watch those pluses or minuses. They do tend to kind of sneak up on you. But we do have 6 solutions for this problem. So I would write all 6 of those. The nice thing is when you do them like this, you're going to have them in order. So you'll get all your solutions that you can write in order. Okay, I want to try one more. And this time I want to do one where we don't even do a full rotation. So this one's going to be real quick. Let's do 3 cosecant of x over 2 plus 3 equals 0. Now, I know people get a little weird about writing something like this, that maybe x over 2 doesn't make a lot of sense to you. It really just means the same thing as this. I'm going to rewrite it in a way that maybe makes a little more sense. 3 times the cosecant of 1/2 x plus 3 equals 0. No matter which way we write it, that 1/2, or dividing by 2, That means that we're going to have to do, either way you write it, half of a rotation to get all of our solutions. Okay, so this time we're only going to do half of a rotation. If there's not an answer within half of a rotation, then there's not a solution to this. All right, so my process for solving this is just like it was with every other trig function, or trig equation that we've had. We're going to start by trying to isolate that trig function. So I'm going to subtract 3 from both sides. And then I'll divide both sides by 3. Again, because that's what cosecant is being multiplied, not what x is being multiplied by. So I get cosecant of 1/2 x equals -1. Now I want you to think about your unit circle. And I'm going to just draw a little guide for a unit circle up here. So if we have this as our unit circle, we are only looking for answers that fall within a half of a rotation. So a half of a rotation would take us from 0 to pi. So we only want answers that fall between 0 and pi, because that's what that 1/2 means. Where is cosecant equal to -1? So think about, when is sine flipped going to give you -1?
3 pi over 2.
Good. So we know the solution that we would need to get is here at 3 pi over 2. That is when cosecant of x is equal to -1. The problem is that's not in the first half of the circle. Okay? So there's no solution in a half of a rotation that will work for this equation. So what I do is I write, you can just write no solution. That's our ultimate goal. But I'm going to make sure we explain why. Okay? So no solution. That's our answer. I'm going to write here because it'll be helpful when you look back at this later. There is no angle in half of a rotation, and I'll just put between 0 and 180. That has a cosecant of -1. So our answer is just this, no solution. Okay, and that's what you could write if you were doing this in your homework and you came up with a solution that looks like this. You could just write no solution. This is for you. This description, this example, or this explanation is for you. So you know why there's no solution. Because it looks like we should have one. We know where cosecant is equal to -1. It just, unfortunately, doesn't fall within half of a rotation, which for this equation, that's what we needed.